Okay, this is problem number 3 on that worksheet that I gave you. So I'm going to do this one out so you have an example. Okay, so here's our function right here, y equals x to the 4th minus 2x to the 3rd. So we talked about the step-by-step process and how to graph something like that because we're looking for the maxes and mins and we're looking for the points of inflection. So step 1 was to get the first and second derivative. So the first derivative, y prime, is going to equal 4x to the 3rd minus 6x squared. And then the second derivative, y double prime, is just the derivative of the first derivative, so that's going to be 12x squared minus 12x. Okay? Then, step 2 was to set the first derivative equal to 0 because those are going to give us some critical numbers, and we're going to, at those critical numbers there could be a max, a min, a point of inflection. So let's set the first one equal to 0, the first derivative. So 4x to the 3rd minus 6x squared equals 0. So out of this, I can factor they both have a 2, they both have x squared, so I can factor out a 2x squared. And that leaves me with x, and then what's left here? Minus, oh no, sorry, not x, 2x, because it was 4. So 2x minus 3. So then remember, this can be 0 or this can be 0 to make the whole thing 0. So we've got x equals 0 as one critical number, and x equals 3 over 2 as the other. Okay? Now, what I taught you to do as step 3 was to plug these numbers in to the second derivative, okay? And then we were going to look at if they were positive or negative, and that was going to help us figure out if it was a max or a min. So let's plug the first one in. So here's our second derivative just to remind ourselves. Y double prime equals 12x squared minus 12x. So if I plug in 0, I have 12 times 0 squared minus 12 times 0, which actually equals 0. Now that's interesting because we only talked about knowing what to do when it was positive or negative. Well, because it equals 0, we're going to test the second derivative in a little bit. We're going to set it equal to 0, and if it also is 0, then we know that's actually a point of inflection. So now let's do x equals 3 over 2. So it's going to be 12 times 3 over 2 squared minus 12 times 3 over 2. And I'm going to tell you right now that that equals 9. I don't want to take too much time to do out that algebra 1 type stuff, or pre-algebra stuff. So it's 9. If you need help with this, you can always come see me. Now, because we know it's 9, that means that it's positive. The second derivative is positive at that x value of 3/2. So that means it's going to be a min. And we know that it's going to be a min because if we think about it, we know that the slope, the first derivative, the slope or the rate of change is going from a negative to a positive because the second derivative is positive, okay? Now, we now know that it's a min, so we want to write down relative min, and it's going to be at 3/2, comma. Now, if we want the y, we have the x. We know it's when x equals 3/2. We want to know what is y equal when x is 3/2. We plug that into the original up here. Okay, and a lot of students have asked, well, how do I know what to plug it into? And I say, think of what you're looking for. Are you looking for a point, or are you looking for the slope, or something like that? You're looking for a point. You have the x, you want the y, which means you're always going to be plugging it into the original. Okay, so when we plug in 3/2 to the original, we end up with negative 27 over 16. Okay, so this is our relative min located here. All right, now for step 4, I taught you're going to look at the second derivative. So we're going to set the second derivative equal to 0 to look for any points of inflection. So 12x squared minus 12x equals 0. So we can factor a 12x out. So we have 12x times, that leaves us with an x minus 1. So we know that x equals 0 or x equals 1. Okay? All right, so now what I'm going to do is I want to figure it out, well, what's the ordered pair? I know what x is, but what's y? Because I want to write it as an ordered pair. So again, I take this and I plug it into the original up here, okay? So 0, comma, when I plug 0 in, I end up with 0. And when I plug in 1 to the original, because that's another at x equals 1, there's something going on, I end up with -1. So I know these 2 points might play a role as well in my graph. So now what I'm going to do for continuing, well actually no, now that we have those 2 points, let's continue on to step 5. And what I told you for step 5 was to create a sign chart. So we want to make sure these are points of inflection. So we are going to create a sign chart and make sure it's changing from positive to negative or negative to positive. So now we know, because our critical numbers for the second derivative were 0 and 1, those are going to be the 2 numbers on our chart. So we're going to pick a number less than 0 to plug in. And remember, you're going to plug it into the second derivative. You're not plugging it into the original, because otherwise that would give you a point. You don't care about that. You're not plugging it into the first derivative, because that will give you the slope, and that's not what we're looking for. We're looking at the second derivative. That's what we want to know what's going on. Is that changing from positive to negative? So if we plug in a number less than 0, we end up with a positive number. Okay, so like let's say you plugged in -1, you'd end up with a positive number. Then plug in a number between 0 and 1, so somewhere in here. So if we plug in a half, we're going to end up with a negative number. And then plugging in a number greater than 1, which we know we plugged in 3/2 over here, which is a number greater than 1. We ended up with 9, so that's a positive number. Okay, so it's going from positive to negative to positive, so those are our points of inflection. So we also know the concavity. So we know it's concave up when the second derivative is positive, which means it's concave up from -infinity to 0, and then from 1 to infinity, because here's where it's positive. So all the x values starting all the way over here, all the way up to 0, it's positive. And then it's negative in between. And then starting at 1 all the way to infinity, it's also positive. So it's concave up on those intervals. Now, when is it concave down? Well, it's concave down when the second derivative is negative. So in this case, it's concave down from 0 to 1. So now we have all of this important information, and we're going to use it to draw a graph of the curve. Okay, so again, I said the thing that I'm looking for is your specific points. So let's look. We're looking for this relative min right here, and we're going to also plot our 2 points of inflection, and then knowing the concavity is going to help us draw the curve. Okay, so let's plot our points right now. So let's see, our first point is 3/2 -27/16. So let's make this nice and big. So we're going to call this -1, -2. We'll call this 1, 2. And again, this is our x, y. We should have the arrows there, x, y. We'll call this 1, and we'll call this 2. We'll call this -1 and -2. So 3/2, that's going to be right about here, and then -27/16. Well, that would be, if it were -32, that would be 2, so it's going to be slightly under 2. So let's toss it right around here. Good. And then we have another point, and that point is 0, 0, and that's a point of inflection. And then we also have 1, -1, so 1, -1 right here. Okay, so now we have these 3 points, and they are 3/2, -27/16. And this one was 1, -1. And this one right up here was 0, 0. So you probably want to mark them just so that I know in case there's any confusion. These are pretty obvious because of where we are, but this one you might want to label so I know exactly what you're doing. So in terms of concave up, it's concave up all the way from -infinity to 0, meaning everything over here is concave up. Remember, concave up looks like this, concave down looks like that. So we want it to be going up like a bowl catching food. So it's going to go all the way up until we hit 0. So again, concave up. Look at how it's kind of like a bowl that could catch food in it right there for you. Then at 0, between 0 and 1, it goes to concave down. So again, I talked with you guys about concave down looking like you're dumping out the bowl. So notice how that looks like part of a bowl that's dumping out the food. And then from 1 to infinity, it's concave up. So again, now we know this is a min, so it makes sense that we would come in like this and that it would look like a bowl and then go up. Okay?